Okay, so I'm going to give you a minute to jot down these. I've got a couple of little definitions for you. So put these in your notes, and then we'll talk about it in just a second. I'm not going to fit on all this. Good paper. All right, a relation is a mapping or pairing of input values with output values. That sounds kind of vague, right? That's because a lot of things can be a relation. So a relation just means we have inputs and outputs, and that's the only real thing we need in order to make a relation. Our inputs is called the domain, and outputs is called the range. Do we know those words? Okay, what variable do we use to represent domain? X. Okay, what about range? Okay, so if you want to make a note to yourself, that's typically what we're going to see. A relation is a function if there's exactly one output for each input. So functions, a relation is pretty much anything that has inputs and outputs, but in order for it to be a function, we have exactly one output for each input. So let's take a look at some different examples. So this is that mapping thing I was talking about. So it says identify the domain and range, then tell whether the relation is a function or not. Okay, so what do we think the domain is going to be for this first example over here? -3, 1, and 4. All the inputs. All we're going to do is just list them out. In order from least to greatest would be nice. All right, what about the range? What's the range for this first problem? Yeah, all these ones, I'm going to put it in order from least to greatest. So -2, 1, 3, 4. Okay? So now the question is this a function?
No.
No, why not? For the input 1, we had 2 different outputs. So this right here makes it not a function. Okay, let's come over here. The domain for this one. What's the domain? Yep, -3, 1, 3, 4. What's the range? -2, 1, 3. Is this one a function? Yes. Okay. Is this okay right here? Yeah, it's okay if we have the same output value for 2 different inputs, but this one is a function. Okay? All right, next. let's look at a table and let's graph some points. So it says graph the relation, and then again, I want you to tell me whether or not it's a function or not. So -2, 2. By the way, you guys know how to make a graph in your notes really quickly. All you need is X and Y axis. And for -2, 2, I would do this. -2 up to put a point. Don't try to draw a whole grid and everything. All right, so -2, 2, 1, -1, -2, 0, and 1, 2, 3, 1. Is this one a function? Oh, what did I do? Yes, what am I doing? Evens. Okay, all right, 1, -1. There we go. Okay, that's right now. But is it a function? No, still not a function. Why not? Yeah, and it's right here. -2 is giving 2 and 0 as an output. So this one is not a function. Anyone remember the name of a test we can use on graphs? Vertical line test. Yeah. So we take our vertical line, oh, and right there it's touching the vertical line twice. That's how we know it's not a function. All right, let's do this one. -3, 1. Hopefully I graphed these correctly this time. -1, 2. 1, 2. And 2, 0. There we go. Is this one a function? Yes. Function. Okay, passes the vertical line test. Each input, exactly one output. Oh, look, vertical line test. You guys already knew it, but here's the definition. So put that in your notes real quick. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. All right, next we're going to be graphing some linear functions. So before we do that, right here, there's some different forms we might see of equations of lines. Anyone know one form? Yeah. Slope-intercept form. Slope-intercept. Remember the formula for that? Slope-intercept. I can't spell English. Y equals mx plus b. Intercept. I was writing intersect. Slope-intercept form, y equals mx plus b. Anyone know another form for linear functions? There's two more I'm looking for. You know one? Standard, yes. This is the one people forget about. Standard is ax plus by equals c. There's one more I'm thinking of. Yeah. Point slope, exactly. Point slope, that's my favorite one. Okay, this one is y minus y equals m times x minus x. You guys have probably graphed in these two forms before. You may or may not have graphed in standard form. So slope-intercept, math people, we're not very fancy. We name things based off of like the most obvious thing. This is called slope-intercept because this is a slope and this is the y-intercept. Point slope is because this is the slope and this is a point. Okay? And then standard, I don't know why that's called standard form. But anyways, I know you guys have graphed with these two. On your quiz on Friday, on the test next Friday, you're gonna have to graph in the different forms and you're not allowed to change it to another form. So especially on this one right here, I don't wanna see you solving for y and then graphing it from slope-intercept. So I'm gonna show you how to do that. Believe me, it's actually easier to graph in standard form than it would be to change it around. Okay, so let's start with this one. Which form is this? Slope-intercept, so where should we start? 5, the y-intercept of 5. Okay, so 1, 2, 3, 4, 5. Where do I go? Yes, I say up 2 over 1. I mean the same thing, just another one. Up 2 over 1. How many points do I need to make a line? By definition, you only need 2. Your teachers in the past may have said, draw 3 so it looks straighter. You can draw 100 points. I don't care what you want to do, but by definition, you only need 2 points to make a line. I'm going to use this so it looks decent. And we should always make our line go to the end of the graph. And what else should I draw on these? Arrows. Okay, so please don't connect these 2 lines and make a little segment and stop. Draw it across the whole graph and put arrows. All right, here's another one. Which form is this in? Standard. And notice it says, do not change the form. Okay. What could make this easier is, well, before we get there, let's talk about intercepts. The x-intercept is what's special about the x-intercept? Y equals 0, so I could put a 0 right here, right? What about the y-intercept? What do we know about that? X is equal to 0. So what I'm going to do is I'm going to plug in 0 for the x and the y, and then solve for the other one, and it should give me the intercepts. So here's what I mean. Let's plug in, we'll do the x-intercept first. So if I plug in 0 for y, wouldn't this just go away? And now we have 3x equals negative 6. So what is the x-intercept? There we go. Negative 2, 0, put it on the graph. Now I could solve for the y-intercept by plugging in 0 for x. So that would make this go away. And I have negative 2y equals negative 6. So what's the y-intercept? 3. Yep, positive 3. So 0, 3, 1, 2, 3. There we go. We have our 2 points to make a line. Isn't that easy? You could even do it in your head, because if you just cover one up and you're like, oh, that's 3, that's negative 2. Plot the points. Draw the line. Have you guys graphed like that before with standard? Okay, that's the one where it's like sometimes yes, sometimes no. Okay, there's the line. So on the homework, it doesn't say not to change the form, but I'm telling you, there's a section where you're graphing. I don't want you to change the form. So do not solve this for y and then do slope-intercept. All right, and last part of our notes, evaluate the function when x equals 2. All right, so I see that word evaluate. So what does that mean my answer should look like? A number. It's going to be a value, okay? So it says when x equals 2, so what do you think I should do here? Substitute 2 for x. Everywhere I see an x, actually. So this first one, I'm going to write f of 2 equals 2. Is there anything else to do here? No, because this doesn't mean f times 2. This just means, that's function notation. It's saying when x equals 2, the y value is 2. There you go, we're done. All right, for the next one, let me plug in 2 for x. F of 2 equals 2 times 2 minus 5. Now we can simplify that. So what is that going to give us? Negative 1. 4 minus 5, so negative 1. Okay? And my last one here, f of 2 equals 2 squared minus 7 times 2. So what do we get when we simplify that? Negative 10, yes. like how I went from year to year?
No, it's like,
What do you mean? Oh, instead of putting this over here?
Yeah.
No, you need to write the F of 2 equals.
well, no, I'm talking about like the other.
Oh, this one?
You put 2 to the power of 2.
Yeah, I guess so. Okay, that's it for the notes for today. So go ahead and get started on your next worksheet, worksheet 2. I think almost everyone in 5th period finished it, so I think you guys should definitely be able to finish it. We've got until 2:29. Oh yeah, you got plenty of time.